In this video, we are going to talk about the input parameters and how to initiate chemical shift projection analysis, or CHESPA. You can start CHESPA here. First NMRFAM, then perturbation analysis, and then CHESPA-SPARKY. CHESPA requires 3 different states which will form 2 vectors for the analysis. The reference vector originates from the non-inactive state to the non-active reference state. In the case of pKa, the active reference state is the apo state, and the non-active reference state is the effector, cyclic AMP bound state. Then we project the perturbation vector on top of the reference vector to measure the fractional activation. The perturbation vector is different from the reference vector because here you have 2 options. The first option, 1, 2, 3, is to originate your perturbation vector from the inactive reference state to the perturbation state. If the perturbation state is an active state, the fractional activation x will be positive. The second option, 2 to 3, is to originate your perturbation vector from the active reference state to your perturbation state. This option is more efficient in investigating inhibition. This way, if your perturbation state is an inactive state, the fraction inactivation x will be negative. For this video, we are going to use the 2 to 3 option and use the antagonist RP state for the perturbation state. Other parameter to consider is the n-dimension correction factor. N15 has a lower gyromagnetic ratio, which leads to a much larger chemical shift on the n dimension than h dimension. By applying this factor, we minimize distortion to chemical shift analysis. We recommend a factor of 0.2 for your initial attempt. Another issue to consider is to exclude small and subtle chemical shifts for a reference and perturbation vector, as these subtle chemical shifts can sometimes lead to unreliable fraction activation or inactivation. We recommend excluding the chemical shift differences lower than 0.05 ppm for both vectors. Additionally, there is also an optional filter to eliminate errors derived from signals that are too close to each other. You can either use the user option, the option to input a chemical shift difference by yourself. The default is 0.05 ppm, or you can use the average line width. However, this option requires you to integrate the peaks before you start. We are using the 0.05 ppm here. Once the parameters are set up, you can click Analyze, Start CHESPA. The results will be available momentarily and will be loaded once finished. You can also save the result folder to a different name by using the Save option. This is how you start a CHESPA. In the next video, we'll demonstrate how to visualize these results.